All right, here we go. So in this next video, what we're going to do is we're going to solve exponential equations, which we actually did in way back in Unit 2. But this time out, okay, we're going to make use of logarithms and calculators. All right, so this one is a little bit different, but let me just take a moment to remind you of something that we did back in Unit 2. We did questions like this right here, just kind of making one up off the top of my head here, okay, but we did things like this right here, where you would solve for x, but notice that the numbers 9 and 27, those numbers are compatible. You can make these into the same base very easily. You can convert both of these numbers to powers of 3. And by doing this, okay, then you can get the bases the same, and then you can use your exponent rules, and then you can solve for x from there. Okay, so numbers like 9 and 27, they work really nicely together. But if you look at the example that's in front of you, 4 and 51, you cannot make those bases the same. So the approach that we learned back in Unit 2 is not going to work for this question. So instead, we're going to make use of some of the log rules that we learned back in the previous unit. So if you recall from the previous unit, okay, if we did a question like, say, this right here, again, just kind of making something up off of the top of my head here, all right? But if you had something like this, you had basically you had one log equal to another log. You could cancel the logs out and just say x plus 5 is equal to 2x. Well, in this case, okay, we're doing more of the same thing, but we're working in reverse. Instead of canceling the logs, we're going to put a log in front of each side. And if you do it to both sides of the equation, then the equation will remain balanced. And from there, the whole purpose of putting a log in front of each side is so that the exponent of x, you could bring that down in front using another log rule that we learned in the previous unit. Okay, we learned that you can bring a number up as an exponent, or vice versa, you could bring it down as a coefficient. And in this way, okay, you could actually solve for x because it's no longer an exponent. You could solve for x by dividing both sides of this equation by log 4. And then from there, okay, you can get a decimal approximation using your calculator. So you can go log 51 divided by log 4 in your calculator, and of course we're rounding to 3 decimal places, so we would say approximately 2.836. Now, one way of checking your answer, at least seeing if your answer makes sense, is if you return to the original question and you're looking at exponents, okay, you know that 4 to the power of 2 is equal to 16. And then if you go up to 4 to the power of 3, that's equal to 64. So if you're trying to figure out what the exponent is, 4 to the power of what is equal to 51? Well, 51 is in between 16 and 64, so you would expect the exponent to be in between 2 and 3. And 51 is actually closer to 64 than it is to 16. So you would expect the answer to be closer to 3 than 2. So an answer of 2.836 definitely makes sense. Okay, so what you can do next is you can pause the video and try these two questions on your own and see if you get the answers that are below. Okay, now we're going to do another example right here. This one is just a couple of extra steps involved because you see with this example, the exponent is not just x, it's a binomial containing the variable of x. So in this case, okay, it's more or less the same, but there's just a couple of extra steps involved. And once again, with any exponential equation, you would want to see if you could work it out without using logarithms first, like we did back in Unit 2. But if you look at the bases, once again, 3 and 74, those numbers are not compatible. So once again, okay, we're going to get the logarithm of each side. The whole purpose of getting a log is so that you can bring down that exponent in your next step. It just so happens that this time, the exponent is a binomial. So you're going to take down that binomial expression, and probably a good idea, because it's two terms, probably a good idea to put that in brackets. So in this case, okay, you get something like this right here, and you still want to divide both sides by log 3 because you're trying to get that x by itself. So in this case, okay, if we divide both sides by log 3, you get something like this, and then you can make a decimal number, rounding to 3 decimal places. Once again, you could go log 74 divided by log 3, and you're going to get approximately 3.918. And here, you just go a couple of extra steps to try to get x by itself. So you're going to bring the 1 over. So you're going to have 3.918 minus 1, which is 2.918. And then you're going to divide by 2. And when you divide by 2, you're going to get an answer of approximately 1.459. And that is it. So after watching this video, okay, you can return to the major log worksheet that we were working on for a while now. You can go back to that sheet, and you can work on numbers 7A through D on that page.